50 years. Then, about 6 years ago,
I woke up one morning in spring morning, and I felt a trembling in my left arm. And I said to myself, I think I have Parkinson's.
Down.
It took some time to get the diagnosis, but Ed sadly was correct. He was one of the 60,000 people diagnosed with Parkinson's each year. Ed's taken it hard. He says he feels let down by his body and struggles at times to accept what the future may hold.
I don't feel I'm in control. That's for sure. I know I can't do what I used to do, but I have a passion for it, and I'd rather do it this way as a dancer and a singer. Then those are my two passions. So I'm using those to fight off or manage this disease.
We're going to do a white.
Debbie Braganza is a former ballerina who teaches the class.
They've got to keep moving. That is one very, very important aspect of Parkinson's that they're finding out. It's just as important as the medication to keep moving.
And in, out, and in.
After a warm-up, Braganza launches into fairly complex routines that include dance exercises like arm movement and footwork.
5.
Some of it's done while seated,
Breathing out.
others at the bar.
We're going to brush front and back.
All of it is to improve flexibility and strength. One of the biggest issues with Parkinson's is a loss of body control.
Dance class is great because it's the
Yo, how are you? Good. Sorry. So, yeah, how was your session with Rena? Good. Yeah, so I'm in room 2020. Okay. Did you get dinner yet? Okay. What did you eat? Okay. Okay, sorry. I was laughing and snot came out of one of my nostrils. It's like weird. Gross. Like I don't even know what I'm telling you. um, yeah, sorry. I feel clumsy. Um, it's okay. So I'm gonna keep this one short and simple. Partially because like the things that you've done, I looked at and they're like very good, and also like I was like wondering about what 1.3 through 1.4, 1.5 were, and they're obviously all the things that were in the last two quizzes. And I feel that like we don't need to dedicate a session to review those things. I feel that we have like reviewed those thoroughly, and equally importantly, you've done very well in your quizzes. Excellent job. I was very very happy with like the 92, even though I'm demanding and I want 100. um, but what is it? Yeah, so like basically anything you need to review from 1.1 through 1.5, I'm just gonna represent in the test I'll write for you, and I will write. I will send the test by like 1 p.m. tomorrow, and like we were supposed to meet at 7 tomorrow. So what I'd like you to do is like in that time, I would like you to work on the mock test, and anything we need to review. Then we will meet like for as long as we need, but This one, as I said, I'm going to keep short and simple. Sure?
Yeah.
Okay, cool. All right. Now, so on this first page, like, what would be my comment about problem 1?
Could you repeat that, sorry?
Sure, no problem. So what would be my only comment on problem 1?
Something quick?
No. On what's on your page here?
Oh, okay. No, I didn't know.
It's okay. It's okay.
Problem one.
Sorry, no problem. I'm asking you to like read my mind. So like this is stuff you already know. Sorry for like repeating myself, but get everything to one side and don't forget your plus or minus. And for problem 2, it's obvious like once you got everything to one side, it's group factoring that you have to do, and that's really the tool you have for cubics. And that's the only thing you need to keep track of, and you're very good at that. So I needn't say more. Here's what I'll do though. Like, so suppose on problem 2 at this step, the factoring had gotten you to x squared plus 4 times 2x minus 3 equals 0. Obviously, the 2x minus 3 equals 0 would get you the positive 3 halves that you should have had here. But instead of x squared minus 4, obviously, like, very well done on x squared minus 4, seeing that it's a difference of squares, and you factored it as x plus 2x minus 2. But what if it were x squared plus 4? What would you have done? If it's x squared plus 4.
Would it be just plus and plus?
It's okay. So when you have like a square term followed by a plus sign and not just a number, no middle term, that's always non-factorable. So we just can move it to the other side, the constant, and so you get negative 4. Tell me how to finish from here.
Sorry.
It's okay. It's okay. You had a long day and a lot of tutoring. Go ahead.
So if it was
Mm-hmm. So,
Yeah.
go ahead.
would you just multiply 0 times 6 times?
Oh, from this we're good. Like so, like I'm saying on a similar problem on this step right here. I just started on that step. You had gotten to, or previous step, you had gotten to x squared plus 4 times 2x minus 3 instead of x squared minus 4, and so the 2x minus 3 would have gotten you the 3 over 2. I'm saying like if it was x squared plus 4, the first thing you should do is move the 4 to the other side, so you get x squared minus 4. Where do we go from here, from x squared minus 4? Sorry, x squared equals negative 4.
You want me to treat it as if the 2x minus 3 was.
Ignore that part. You would have finished that part. So how essentially what I'm asking is how do you solve x squared plus 4 equals 0?
Oh, okay. So
It's okay. I wasn't clear.
I guess I removed the 4 dollars.
Uh-huh.
Equals negative 4 and then square root both of them to 2i.
Exactly. Don't forget your plus or minus, but 2i. Excellent. Okay, that's it. Okay, all right, keep it moving. So here, it's solving radical equations. This is somewhat new, but it's not a big deal. So first thing first, remember radical equations come with extraneous solutions. So in the end, make sure you check your solution, plug it back in, so that you don't get a negative number under the square root. But otherwise, like, on simpler ones like 3 and 4 and 5 and 6, what you should do is, if there's only one expression with radical, isolate it, right?
Yeah.
And then from there, square both sides and solve as you would normally. So, like, I suppose 6 is the only one that we ought to, like, maybe write a little bit. So, doing exactly what I was just saying, you would have gotten root x plus 3 is equal to x minus 3. You square both sides. On the left, you get x plus 3. You've written the steps. On the right, you get x minus 3 squared, and you expand on the right side, get everything to equal 0, and move forward from there. I'm going to create similar problems like this and for your mock test. And so, you know, I will see how you're going to deal with them. So we don't need to say more on this page. Okay, so here, this one. So this is like a situation where you have two radical expressions both on the same side. And what you chose to do is move one of the radical expressions to the other side. That's perfectly fine. You could have also squared exactly as it's written, which is you could have like done root x plus 5, and then, sorry, it's a minus sign in between. So minus root x minus 3, and you could have squared here and written equals 4, squaring both sides, and gone from here. But I actually really like what you chose to do instead. And I read through the steps, and for example, I know that you did the correct thing from here to here, and that's really the most important step from, if we number them, this is step 1 and this is step 2. Going from step 2 to step 3 is the most important thing to know how to do, and you navigated through that nicely, so I'm not going to say more. Deal with a similar problem exactly the same way. Now, sorry. Otherwise, you know, just as I said earlier, like make sure that you plug back the answer, in this case x equals 4, to make sure that it doesn't give you a negative inside any of the radicals. And it doesn't in this case, so you're good. Then next, we're talking about like fractional exponents, which are called rational exponents. So this is like also new, and the only thing, you know, for example, in problem 5 is like add the constant to both sides, so you get equals positive 4. So the only thing that's crucial is that you know how to interpret x to the 2/3, and you've correctly done that on this paper clearly. So you said that that's the cube root of x squared, and that's right. The other interpretation would be like the cube root of x squared, like that. It doesn't matter. Like the way you interpret it is perfectly fine. And so then you took the square root of both sides. Is that what you did to go from this step?
Yeah.
Okay. So when you square root both sides, though, shouldn't you get positive or negative 2 on the right side?
Positive or negative 2
Ye-
equals 4.
Yeah, so like we interpreted x to the 2/3 correctly as you have written here. Now what I'm saying is from there, what would have been your next step?
Square root.
Exactly. And what I'm saying is when you do that, you get cube root of x is equal to exactly plus or minus the square root of 4. But that leads to two equations. One of them is cube root of x is equal to positive 2, the positive square root of 4, and the other is cube root of x is equal to negative 2, and from here you cube both sides, right? Yeah, so one of them gives you x equals 8, the other gives you x equals negative 2 cubed, which is negative 8. So that's my only comment there. Next one, hold on. It's a little bit hard to read, but hold on. I think I could blow it up a little bit. Hold on, sorry. So it says 5x to the what power, kiddo?
5 and 3 for
To the 3 over 2?
second.
Okay, so it says 5x to the 3 over 2 minus 25 equals 0. So talk to me about your steps here. Go ahead. Yeah, let's go with a 2.
Yeah, okay, so, from there, yeah, that's 3 over 2. I don't know why.
It's okay.
Let me just double check because I have it on my phone.
Okay, no problem.
Sorry about that.
It's okay, don't worry. You're too polite.
Okay, for 6, right?
Yeah.
Okay, so yeah, that's 5x to 3 over 2 equals 25.
And where to from there?
So I multiply by the reciprocal fraction and then I get rid of it. So
Yeah, first let's get rid of our 5 right there. So we divide by 5 on both sides, don't worry. So then we get x to the 3 over 2 power is equal to 5. And so I would heed to the advice right here, which is that like exactly as you said, raise both sides to the reciprocal of the a fractional exponent, right?
yeah.
Okay, so we raise both sides to the 2/3 power. On the left, you just get an x. On the right, you get 5 to the 2/3 power. By the way, we could have done exactly the same thing once we add 8 to both sides in problem 5 over here. So we could have moved in a similar path. But I like the way we approached it over here for problem 5, so use either. Anyway, now that we have x equals 5 to the 2 over 3 power, how do we claim that?
So I just put like the denominator by the cube root of 5 squared.
Exactly. So that would just be the cube root of 25, and 25 is not a perfect cube, so we'd have to leave it like that. All right, cool. So then next is equations that are quadratic in form. Yeah, so this is maybe something that we did very late on in algebra 1 that summer, and but anyway, like here's a very easy way for you to identify on your test that it is you're dealing with an equation that's quadratic in form. It will not be a quadratic, obviously, because like immediately looking at it, like this is a quartic, and this is a sixth degree. So that's first thing, is that the highest powered x will be more than 2, and it will be an even power. It will have to be an even power. So that's one way you identify. So highest power is even. Highest power even, more than 2, and greater than 2. So that's number 1. Number 2 is So number 2 is it will have 3 terms. Just like a quadratic with all the terms showing, it will be 3 terms. Okay, so 3 terms. And then finally, number 3 is the middle term. The power on x, if you square it, will have to be the highest power. For example, and the example that you're given right here, the middle term exponent is x squared. If you square that, you get x to the 4th. So that will always have to be the relationship between the middle term and the leading term, which is that, I just said it, I won't repeat myself. But these are 3 very important ways for you to recognize that it's an equation that's quadratic in form. Any questions? Okay, cool, thanks. So, like, can you use the reasoning that I just gave to explain 8?
Let's do 8.
Yeah, or like talk about how you would have known it's a quadratic in form.
So I guess like x to the 6 is like put the x to the 3rd.
It is, exactly. So that's one way, and it has 3 terms. And I wrote 3 like ways to recognize it. The 2 ways that you just said are sufficient. Fair?
Yeah.
Okay, cool. And so then we have like, let's do this one out, and we will conclude on this one. So you have this, and then equals 0. So fine. Now that you've recognized that it is quadratic in form, what are the steps to do?
I guess like you could say like for this one, would you say like u equals x to the 3rd?
Exactly. You always want to say u equals whatever is the middle x. Exactly. And so when we do that, then x to the 6th becomes what?
U squared.
Exactly. So then we have minus 10u plus 9 equals 0. Now it's become a simple quadratic only using the letter u. Go from here.
Okay, so I guess using factoring,
Mm-hmm.
that would factor into minus 9 and minus 1.
Exactly. Beautiful. U minus 9, u minus 1. Okay, equals 0. And then from here, what do you do?
You would be either 9 or 1.
Okay, so u equals 9 or u equals 1. Uh-huh. Good. And so then from there?
And so from there, since u is x to the third, we have to square those answers.
Well, yeah, so if you substitute back for u, and so you're going to get u is equal to x to the third, so you're going to get x to the third equals 9, and x to the third equals 1, right?
Yeah.
Okay, and so where to from here?
So you want like x to the 6, right?
Well, we just want to finish from here. So how do I solve something like x to the third equals...
Like, take the cube root.
Exactly. Can you explain to me what you misunderstood in that part when you thought we should say x to the 6th?
No, I just thought that it simplified like u to x to the third. I thought it was going like that.
Don't worry, no worries. Okay, you in the end knew what to do, no pun intended, no. One of the solutions is u equals cube root of 9. Obviously, 9 is not a perfect cube. 27 is. 9 is not a perfect cube, so we leave it at that. And x equals cube root of 1 obviously simplifies to just 1, right?
Yeah.
Okay, all right, kiddo. So I want to say one little thing before we conclude. So, like, if you would called back like what u was in this factored part, notice that like in this step, notice that what it would have read is it would have read x cubed minus 9 times x cubed minus 1 equals 0. And so the x cubed minus 9 is just going to lead us to the same place, which is x equals the cube root of 9. But x cubed minus 1 actually doesn't just give us 1, it gives us 2 other solutions. So, like, in this part, actually, we should have been more cautious, like, in this part, because the answer is not just 1. And I don't know if your teacher showed you this detail, and I don't know if you will be expected to, like, show what the other 2 solutions are from here. But remember difference of cubes, a cubed minus b cubed?
Could you repeat that for them?
Yeah, sure. Remember difference of cubes, a cubed minus b cubed?
Yeah.
How does that factor?
A cubed plus b cubed is a cubed plus it like a squared and b squared or something.
Yeah, it's okay. Don't worry. So I will give you the hint of a cubed plus b cubed, which is what you were just talking about, and then you'll help me on this one. So a cubed plus b cubed would have been a plus b. I know this is all you need. Just a little reminder. Times a squared minus ab plus b squared. So how does a cubed minus b cubed factor?
So that would be the first one is a cubed, right?
It's a minus b.
Understand.
Mm-hmm.
And then it's a squared plus ab plus b squared.
There you go. Beautiful. Excellent. Now, so how would you have known on the x cubed equal 1 part, how would you have known to do this? What I'm saying is that, like, for the x cubed minus 9 part, like, and on a similar problem like this, if you get an x to the 6th degree that turns into quadratic in form, this is exactly how I would like you to deal with it. So, like, which is that, like, don't proceed like we have done here, and this part, ignore this part. Like, at this step, call back what u was. which is like plug back what we said u is, which is x cubed. And when you do that, you get to what I just boxed in green. And when you get there, then think difference of cubes, right? And like if it were a plus, think sum of cubes. Now on this part, on the x cubed minus 9, what we did was perfectly fine. It's just going to be x equals cube root of 9. And the reason why you cannot use difference of cubes or sum of cubes on x cubed minus 9 is because 9 is not a perfect cube. Does that make sense?
Yeah.
Yeah, but on 1, it's a perfect cube, as is x cubed. So on that part, you can use this right-hand side. So then use this right-hand side right here to tell me what x cubed minus 1 would turn into.
So that would be x minus 1
Yep.
times x squared plus x plus 1.
Yes, beautiful. Very well done. Excellent. And when you set these equal to 0, obviously from x minus 1 equals 0, you just get x equals 1. That we had already had right here. But from this part, you're going to get two complex solutions. That will always be the case. If you end up using difference of cubes or sum of cubes, this part and this part will always give you two complex solutions. And the way I would like you to find those two complex solutions is by using the quadratic formula. That's the easiest way. You can complete the square, but just use the quadratic formula, which is x equals minus b, which in this case would be minus 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times 1 times c is also 1 in this case, over 2a, which is over 2. Sorry, hold on. So that would be x equals minus 1 plus or minus, and inside the square root we would have had minus 3 all over 2, and so then that would be like, sorry, x equals minus 1 plus or minus, I know I could let you talk, but it's okay, I just want to do it efficiently. I'll have you practice on a problem similar to it. So like this, fair?
Yeah.
Okay, and if you need to separate them, you get x equals negative 1/2 plus or minus, and then I root 3 over 2, and that's two solutions, one with the plus, one with the minus, and with this x equals 1, you actually get 3 solutions out of this. Again, the reason why we didn't deal with the x cubed minus 9 the same way is because 9 is not a perfect cube. Fair? Okay, this is everything I want to say for today. And like I intentionally wanted to practice these sum of cubes and difference of cubes because looking back at your quizzes on the previous sections, 1.1 through 1.5, those are the only ones you need a little bit of reminder on. Everything else I feel like you mastered really well. Also, like, because you did really well on your quiz, I didn't care to see like what little like mistakes were there. And so if there's, I will look again closely, and if there's anything worth mentioning, I will mention that. Like I said, expect my mock test by 1, and I will intentionally only represent the things that I will feel will give you trouble. So if you have problems with like a number of questions, don't worry. I don't anticipate you will. But if you do, don't worry, because I'm intentionally picking like the hardest things and putting them on your test. Fair? Okay, have a wonderful night, and I will talk to you tomorrow.
Thank you. I'm sorry to confuse.
It's okay, don't worry. You have like a very busy life. Like, I get it. Okay. Have a good night.
You too.
Uh-huh.
Bye.
Bye.